Hello and welcome to our presentation on how to use FME in BIM workflows. Today we'll take a look at building information modeling and at the role of GIS and FME in BIM projects. My name is Verena Henners. I'm working for Conterra in our data integration division, and I've now been with Conterra for about 4 years. For those of you who've not worked with BIM yet, we'll start with a quick overview. BIM is short for Building Information Modeling. It's a digital methodology in which data is used to model the planning of a building. BIM is used, for example, in structural and underground engineering, but also for routing projects like road engineering and the planning and building of power lines. A central idea of BIM is to create a digital twin of the object that is being modeled and to record the building or construction in its entire life cycle. Another important part of the BIM methodology is to work collaboratively and to exchange data and information consistently. The strong focus on collaboration in BIM is one aspect where BIM differs from other, more conventional planning methodologies. There it was often common practice to recreate data at each planning phase. In BIM, on the other hand, information is being reused and we're working on one central model that is regularly being updated. This model creates an information base that is used by all of the involved players. This way, they can easily access the information they require, and maintenance is also becoming easier because there's only one central model that needs to be updated. This can help make the project both economically and ecologically more sustainable. A central idea of BIM is to monitor the building in its entire life cycle, from the first initial concept to the planning and construction phase, but also later on when the building is being used and operated. A potential renovation and modernization of the building is also being monitored as part of its life cycle. And the BIM life cycle can also be used to monitor the demolition of a building at the end of its life cycle. GIS data is mostly used in concept and planning phases of this life cycle, but also an important part of the construction phase. We'll now stretch out the BIM lifecycle a little and look at some of the involved data. This box here shows some of the important data sources in a BIM project. As you can see, we require a lot of different data, and those data sets are provided in different formats. Therefore, data integration plays a crucial role to make all of these source data sets accessible. While IFC is a standard format to exchange data in BIM projects, there's not just one BIM format, but data is actually provided in many different formats. CAD drawings are a common data source, but as important formats are raster data, XML data, and also laser scanning data. Many of the data formats that are used in GIS projects also play a role in a BIM project. For example, GIS data is important when it comes to property information and if you want to see and analyze the spatial surroundings of your building. Machinery like excavators also has to be provided with spatial data so that they know the exact location where they need to operate. Non-spatial data is also being provided and has to be integrated as well. This slide here shows some of the players involved in the BIM workflow. They work with different software and have different requirements regarding the data that is delivered to them. So for example, a BIM manager will have different data requirements than perhaps the client or general contractor of a project. So data demands that someone in a BIM project has depend on their role in the BIM project, on the stage of the BIM lifecycle they're working on the software they're using, and also on the focus of their work. It's also very common to have large differences regarding required data by different players, even if they're working within the same organization. The goal should be to provide data in a way that the person receiving it can easily use it in his or her software and access all relevant information. Here are some key points where FME can help. FME can of course be used for data integration and harmonization, and also to prepare data so that it can easily be used within the BIM workflow and is provided in exactly the shape and form that is required. FME can further be used to assess the quality of a data set and to generate reports. And FME can also be used to generate 3D data sets from two-dimensional source data. Here are some additional examples of where spatial data is used in a BIM project and where FME can help with data processing. One example is defining textures for 3D buildings. This can of course be done manually, but if we use FME to create a workspace which we will then automate, we can reduce manual work significantly and speed up the process. Another example is providing a GIS for citizens that contains information on planned projects in order to engage citizens in the decision-making process. Here, FME can help prepare data that is provided to citizens in a way that is easily accessible to them. Yeah, as we've seen, a lot of GIS data is needed in BIM projects. This brings up the question if GIS is the central element of a BIM workflow. The answer is not necessarily. For structural engineering, the overall importance of GIS is relatively low because we're limited to a small geographical area. However, if we're working on projects like routing projects, planning power lines, constructing bridges or tunnels, and so on, then the spatial extent of the project is much bigger, and GIS and spatial data also play a much bigger role. In general, we can say that the importance of GIS in a BIM project increases with the spatial extent of the project. We'll now take a look at a current example from a project Conterra is working on. Here, the routes of power lines are being planned according to BIM methodology. The power lines will be subsurface and they will have a length of several hundred kilometers. BIM methodology is used here mainly to reduce costs and to improve communication in the project. A key issue was that due to the large spatial extent of the project, many properties are concerned, and therefore it's of large importance to manage property information effectively. The planning for this electricity routing project was based on the way the Federal Network Agency in Germany works. This workflow we can see here was defined by the Federal Network Agency, and it closely resembles the BIM lifecycle. The initial project stage was the assessment of requirements. This is where the overall requirements for the project were being defined, the current situation was analyzed, and general steps that needed to be completed were being determined. The next step was the federal specialist planning phase. Here, local spatial conditions were analyzed and an environmental assessment was conducted to define the general area where the project could be realized. Then in the plan definition phase, this plan was being fine-tuned to define the exact route for the project. The two final phases are construction and operations and management. Preliminary investigations are a central part of the plan definition phase. The preliminary investigations are carried out on concerned properties and determine if these properties are suitable for constructing power lines. Each of these investigations work with different data sets, and GIS data plays a crucial role in all of them. For example, archaeological investigations are used to analyze if any historically significant structures are in the area. Underground or subsurface investigations are used to analyze the local geologic profile and also to determine the thermal conductivity of the ground, which can be an important factor in determining if the site is appropriate for building the power line or not. Then we also need to investigate if there are any unexploded ordnances from World War II left in the ground. We can use aerial images to find out if any bombs have fallen to the ground and not exploded, and then of course these ordnances need to be removed. It's also important to determine if any conduits are affected by the power lines we want to build, and to conduct a species mapping to find out if any environmentally protected species can be found in the area. We'll now take a closer look at one of these preliminary investigations, at the subsurface investigation, and at the role GIS and spatial data play here. Planners use a GIS to determine where it makes sense to drill for this ground investigation. The next step is to ensure that we have the right of way to access the spot that has been chosen. To do so, the owner of the property needs to be contacted and needs to be negotiated if, when, and where the property can be accessed. Particularly if the property is used for agriculture, the time when it can be accessed is often of critical importance, in order to avoid any effects to the harvest. Core drilling profiles are then being taken and used to analyze the ground. The results are being documented, and in the end, a three-dimensional model of the ground is being created. Now, some additional information on the first step of the subsurface analysis, so on planning this preliminary investigation. Planning agencies determine where drilling should occur. Once this location has been determined, it is being uploaded to the GIS, to the property management system, and to the stakeholder system using FME. As soon as any data is being uploaded to FME, a data validation process is also being carried out to make sure that only complete and plausible datasets are uploaded. FME is further being used to distribute NAS data, which contains information on properties and their owners. The workflows for integrating data and assessing their quality were created in FME Desktop and have been uploaded to FME Server so that users uploading data can easily do so via FME Server's web interface. In this project, the user was then provided with an Excel report that contained information on datasets that have been uploaded successfully, and also a report on any issues that have been detected within this dataset. Information on the right-of-ways and the negotiation status for accessing concerned properties were documented in a WebGIS. Here, FME was used to regularly update the WebGIS. This way, anyone involved in the process could easily access information on the current status for each of the concerned properties and see which owners have already been contacted and where access has been granted or denied. Routing projects like the example we've just seen that stretch over long distances require spatial data in order to be successfully carried out. FME can support at various stages of this workflow, particularly for integrating required data, connecting systems used by different players, and also for data validation. And Contera can also offer support for integrating data in BIM projects. If you have any questions about this presentation, please feel free to reach out to us either here on the World Fair or just drop us an email. That brings us to the end of this talk. Thank you everyone for your attention, and I hope you have a great rest of your day. Thank you.